Return to the Crowne Plaza another time. The Crowne Plaza at West Central Boulevard here in Los Angeles, California. And we're on the topic, the amazing 5x12 matrix. And the magnetization property of the amazing 5x12 matrix, which is defined as the attractive power it has to incorporate all the matrices operation in different fields into its domain and seek analysis and solutions and understanding. So these operation in the mechanical field was spotted, was brought about by the magnetization property of the amazing 5x12 matrix. And as I promised, I would have projected the micromechanical behavior of elastic constants. And so what we have in general, let's just get into it very quickly as our time is running out. We have epsilon 1, epsilon 2, epsilon 3, epsilon 4, epsilon 5, and epsilon 6. Notice that this has one, what is this now, row above our 5x12. So this has 6 row. And this was now gamma 4. These gammas are different from the one in the rotational matrix. Gamma 5 and gamma 6. And so we could draw here. And in order to, I myself was to alter the form of the matrices given, so that what we have here is sigma 1 over E1 minus V12 sigma 2 over E1 minus V13 sigma 3 over E1. Notice we could take out the E1 and put it over there. Minus 1,4 sigma 4 over E1 minus 1,5 sigma 5 over E1 minus 1,6 sigma 6 over E1. That completes the first column, row rather, which has 1, 2, 3, 4, 5, 6 column. So it's a square matrix, 6 by 6, minus now V21 sigma 1 over E2. I'm going to have to see what's the meaning of these sigmas and these E's and these. Sigma 2 over E2 minus V23 sigma 3 over E2, 2,4 sigma 4 over, everything is over E2 here, minus 2,5 sigma 5 over E2, 2,6 sigma 6 over E2. And so as we go on now, V31 sigma 1. This will be the third row on the first column, second row, first column, first row and first column. So that's over E3 now, minus V32 sigma 2 over E3 plus sigma 3 over E3 minus 3,4 sigma 4 over E3, 3,5 sigma 5 over E3, 3,6 sigma 6 over E3. Going to the fourth, it's also getting out of proportion here. This is for this one. N41 sigma 1 over G4, 42 sigma 2 over G4, 4, 3, sigma 3 over G4, sigma 4, pardon me if I don't put in the commas here. This is like the 4th row and the 5th column. If you count this way, you get 5. 1, 2, 3, 4, 5. Count this way, you get 4. It represents 4, 5, which is the 4th row and 5th column. And this would be 4, 6, sigma 6 over G4. And so on until you get the 6th one here would be minus 6, 1 over G6 minus. This was brought about by the magnetization property of the amazing 5×12 matrix. 6, 2, sigma 2 over G6. And those following can find out the meaning of the parameters in this matrices operation in the micromechanical demonstration. I could sort of briefly, while I'm doing this, 6, 4, sigma 4 over G6 over G6 plus sigma 6 over G6. And we missed out the 5. Let's drop in some 5 here, and 5, 1, sigma 1 over G5. 5, 2, sigma 2 over G5. 5, 3, sigma 3 over G5. 5, 4, sigma over G5. Sigma 5 over G5. And 5, 6, sigma 6 over G5. This is a micromechanical thing in elastic stress and strain. And this was the general form. And we could go on to the orthotropic case. The anisotropic case. And there's another case there, the isotopic, the anisotropic, and so the elastic constant or the engineering representation of micromechanical behavior. Tension, stress, and strains. And there are 6 equations for the orthotropic case. I just did the general form there. For the orthotropic case, the matrices is let's try to drop in the matrices here for the orthotropic case. I'll just take a brief exit and return. The orthotropic case would a lot of these terms would end up in 0. Like all of these terms here would end up in 0. The last 3 would be 0. This is for the orthotropic case. Likewise, this one, 1, 2, 3 will end up as 0. These last 2 in this case would end up as 0. And this last one would end up as 0. And this one will remain 1 over G, 1, 2. So that would be for the orthotropic case. Let's try to see if our visual space will allow it by starting it off here. I prefer to take a break and return with the orthotropic case.